Remember last class we learned two methods of voting. One was called the Plurality Method, which isn't really anything new. It's whoever gets the most first place votes wins, right? That's sort of the method we automatically think about when we think of voting. The tables in here are all messed up. Hold on. Okay, so first method was plurality. That's just whoever gets the most first place votes wins. Natural extension of majority rule. So it's sort of like the most basic way that we vote. And then the second method was the Borda count method, which is also used pretty frequently, very often when you're for awards where people vote, where you rank everybody and then people get points based on the ranks that they receive. So our third voting method is called plurality with elimination. It's also known as instant runoff voting or the Hare method. So here's how it works. Voters fill out a preference ballot once. Everybody goes to the polls, fills out a preference ballot, where they rank their candidates from first to last. So in round one, if one candidate has a majority of the first place votes, and what was majority again? More than half, right? If anyone has more than half the votes, they win and the election's over. We just stop right there. Okay. If no one has a majority, we go to round two, where we eliminate the candidate with the least first place votes. So whoever has the least first place votes just gets kicked out. Say they have no chance of winning, get them out of here. And that moves all candidates who were below that candidate up a spot in the preference schedule and on the preference ballots. And then we recount. Okay, we recount the first place votes. And if anybody has a majority, we're done. If not, we move on to round three, where we do it again. Eliminate the candidate with the fewest first place votes. That moves everybody up a spot. And we recount the first place votes. And we keep doing this until someone gets a majority. Okay. This method is used in Australia, Ireland, San Francisco. Used to be used in Vermont, in Burlington, Vermont. It's used in some student governments and for some awards. So let's go ahead and do the plurality with elimination method on this math club election. This is the same math club election that we worked on last class. So here's my preference schedule. Round one, tally the first place votes. So this feels just like plurality. You say, okay, A, how many first place votes does A have? 14. And B? 4. C? 11, these 10 plus this 1. And D has 8. Okay, so how many total voters are there in this election? 37. Add up these numbers across the top, we have 37 voters. Which means how many do you need for a majority? 19. Yeah, half of 37 is 18 and a half. You need more than that, so we have 19 votes for majority. So we're looking for a majority. The whole idea behind plurality with elimination is to force a majority. All right, does anybody have 19 votes? Okay, so that means we have to move on to round two, where we eliminate the candidate who has the fewest first place votes. So who's that? B. B's got the fewest first place votes. Eliminate B. Now, B had 4 first place votes, right? So these 4 people, this column right here, those 4 people had B in first place. But if B was not an option, you can tell from their ballots who they would have chosen next, right? D. So those 4 votes that went to B before, now that we've eliminated B, they go to D. They go to the next person in the schedule. So in round two, oh dear, why is that happening? Oh, okay, good. All right, so in round two, we eliminate B, and we give those 4 votes to D. So we recount, and we have A has 14, B is gone, C has 11, and D has 8 plus the 4 votes it got from B, which is 12. Does anybody have 19 votes yet? No, okay, so we have to eliminate the fewest first place votes. So who's got the fewest now? C with 11. So we get rid of C. And then we have to go again. And A and D are going to be the only candidates left. So I've got A and D. And A had 14 and D had 12, right? Then we have to take C's 11 votes and give them to the next candidate. So these 10 people who wanted to vote for C, they no longer have the option of voting for C, so who would they go to next? B, but B's gone too, so they have to go to D. So these 10 people are going to go to D. And then there's one more first place vote for C that would also go to D, right? C's gone, so you go to their next choice, also goes to D. So A has 14 and D has 23. 23 is more than 19, so D is the winner. We have a majority. So what do you think the complete ranking would be? Obviously, D's in first place. Who should come in second place? A, because A survived the longest without getting eliminated, right? And then who should come in next? C, because C was eliminated second, right? And then finally B, because B was the first candidate eliminated. Good. So if we can look back in your notes for a minute, we want to write down the winner of the math club election from each of our 3 methods. So plurality with elimination we just did, that was D, right? Who won using plurality? A, and who won using Borda? Points. C? C, okay. Let's see here. Oh, it was B. It was B with 106 points. Thought it was B. This is B. So far, 1 election, 3 different methods, 3 different winners. Okay, our 4th and final election method is called the method of pairwise comparisons, also sometimes known as Copeland's method. Here's how it works. Each voter fills out a preference ballot just once. And as the name suggests, we are going to compare every pair of candidates. So for each head-to-head comparison, the winning candidate gets a point, the losing candidate gets 0 points. In the event that they tie, they each get half a point. All the points are tallied up. Candidate with the most points is the winner. So here's the math club election again. How many voters are there in total? 37. Okay, so we're going to figure out the winner using pairwise comparisons. We have to start by listing all the possible matchups. Okay, so A, we're going to do all of A's matchups. We can match A against B. We can match A against C. And we can match A against D. So those are all the matchups that A can have. A against everybody else. And then we're going to do B's matchups. B against A, but we already have B against A written over here. So we go B against C and B against D. And then we're going to do C's matchups. And C has to go against A, B, and D. But we already have C against A and C against B written down. So we just have C against D. And then D's matchups, D has to go against A, B, and C, and that already has. D has gone against A, D has gone against B, and D has gone against C. So these are the 6 possible head-to-head matchups, the 6 comparisons. All right, so now we're going to look at our first matchup, A versus B. every voter has a preference between A and B. Even if they didn't put either one in first place, they have a preference. We can tell from their ballot who they prefer, A or B. So we're going to look at every column and write down who those voters would prefer. So these 14 voters, if they had to choose, C and D are out. You have to choose between A and B. Who are you going to pick? A. So we'll say 14 votes for A there. These 10 voters, C and D are gone. They have to pick between B and A. Who would they pick? B, because they have B ranked higher than A. Okay, so 10 votes for B now. The next 8 voters, who would they pick if they have to choose between A and B? B. Again, B is ranked above A, so they choose B. So we put those 8 votes under B. These 4 people, would they choose B or A? B, because they have B ranked above A. And the last column, the 1 voter, B or A? B again, 1. So B ends up with 18, 22, 25. Did I add it wrong? 23, yeah, 23 votes. 23 votes. A is 14, so B is the winner here. So we just circle B, call them the winner. So I'll write down here. The final tally was 14 to 23, right? As a quick check, your tally for every pairwise comparison, when you add the 14 and the 23, you should get 37, the total number of voters. So that's just a quick check that you did it correctly. Add your tallies, it should add up to the total number of voters. So now we want to calculate the scores for each of the other matchups. So I want you to do this in your groups. Do the matchups for A, C, AD, BC, BD, and CD. Check with each other as you go. Make sure you got it right. Okay, so what did people get for A versus C? 14 to 23 again, right? And A versus D is also 14 to 23. So a couple people recognized that that was going to be the case without having to add everything up, because these last 4 columns all have A in last place. So no matter who's matched against A, that other person is going to get, A is going to get the 14 because A is in first place here. And no matter who else it is, they're going to get all the other votes. So all of A's matchups are going to be 14 to 23. All right, what did we come up with for B versus C? 18, 19. Quick check, add them together, you get 37. Okay, we did it right. That means C is the winner. How about B versus D? Say that again. 28 to 9. Okay, good. 28 and 9 is 37, so B gets that matchup. 25 to 12, C wins that matchup. All right, so now we calculate how many matchups each candidate won. So once we have all the scores tallied, it's time to award points based on the winners right here for each head-to-head comparison. Okay, so A, how many matchups did A win? None. So A gets 0 points. How many matchups did B win? 1, 2, yeah. And C, how many matchups did C win? 3. And D, 1. So who's the winner of this election? C. And what's the complete ranking? CBDA. Most points to fewest points. So one downside to the method of pairwise comparisons is this method can lead to a lot of ties, right? So sometimes many candidates can tie for the most points. And every time we add a new candidate, adds a lot more comparisons we have to do. So when there's only 3 candidates, let's call them A, B, and C, right? We have to match A against everybody, which is just against B and C. Then we have to do B's matchups, which would be against A and C, but we already have B against A, so B against C. And then C has already been taken care of because we already have C against A and C against B. So there's only 3 matchups with 3 candidates. 3 candidates, 3 matchups. With 4 candidates, which is what we just did, how many comparisons did we have to do? 6. 1, 2, 3, 4, 5, 6. How many do you think there would be for 10 candidates? A lot. 9? Sure, yeah. I like any guess would be good. 36, good guess. You're warmer. Warmer. Warmer, warmer. 45. That's a lot of writing, right? To have to write down 45 head-to-head matchups, tally the winners. A computer could do it. It wouldn't be such an annoying thing for a computer, but to do by hand is a really big pain. So there's actually a formula for n candidates. If you have n candidates, the number of matchups is n times n minus 1 over 2. That's not something I'm really going to hold you responsible for, but you just can see that it gets big really fast because you're almost squaring the number of candidates, right? N times n minus 1. And in case you're interested in seeing a real life preference ballot, like something you would go to vote and they would hand you, this is part of an actual ballot from a Burlington, Vermont mayoral election. Burlington, Vermont used plurality with elimination for a couple of elections. So that's the one we learned at the beginning of class today. But the city voted to go back to using regular old plurality after a couple of elections. So you can see they would have, they had 1, 2, 3, 4, 5, 6 candidates, and you had to rank them from 1 to 6. All right, so before I have you work on the voting activity number 2, which is just practicing the stuff that we learned today, I have some ballots from your classmates who remembered to email me the questions. If you did not email me, you're just going to have to print your ballots yourself and find 20 people to fill them out. Not a big deal.